Okay, I might take one of these out. Okay, we're recording. Excuse me. Welcome back to Friday. We found out I got here early. The doors do open about 7:30, so I will make it a regular habit to get here at 7:30 if I can. Um, and so that if you've got questions, you can kind of have like an extra office hour there. After this class, I do go to my office in ECA 339. I'm there for at least an hour for in-person office hours, and then I'm there for another hour for online office hours. But if no one shows up, you could still come there. So there's a potential of getting 2 hours, and you could stay and work on things. So there's 2 hours of office hours afterwards that you could hang out, get questions answered. Uh, so I encourage you to do that, and that will be Monday, Wednesday, Friday. So I just want to make sure everyone's able to get questions answered that they need to. Um, this will be recorded today. We are adjusting the time. So what we're going to do is we'll finish up 6.2 today, which is the problem solving part of it. Uh, then I'll open it up to any questions you might have from the homeworks from the first one or second. So the goal is that by this weekend, we're pretty strong into the first two sections. Next week, we're going to get into 15, 1, 2, 3. And what I've done is I've moved everything down a day, and I'll throw away one of the in-class quiz things. We just won't worry about it. Those are going to be group work to go over test type questions. So they're kind of getting us ready. We won't quite be there. So next week we get into sort of the calculus part of this class. So we'll remember hopefully some things from 210 that you took, but it'll be a whole new section. So I'm hoping we can go through the weekend and get a real strong start to at least these first two sections. We will, the thing is, what we're doing right now with these two sections, we'll pick up, I believe, either in section 2 of the class or possibly 3 when we get into matrices. So this is kind of like an introduction to there. So I kind of updated the schedule here. I'll update the calendar as well. I haven't done that yet, but we'll get there. We're going to pick up here, but before we do, just any questions about how the class is going or anything at all. Okay, so we'll start off with a little bit of review. Let's see if this works. There we go. So what we're doing in this section is we previously were working on just graphing a series of inequalities, remember? And so we'd graph a line and you graph either above or below. Remember, the way the textbook is doing things is they are shading the opposite. They're shading the non-solution part so that the solution part stays unshaded. It works out much better that way. It can work both ways, but if you've been shading the solution part, then you've got to look, okay, which one has all the shadings? And sometimes that's a little hard with some of these. They have 4 or 5 different things going on. Okay, so I will stick with how the text is doing it. It's not the only way to do it, but I think it's for what they're doing. It'll match the homework and everything. So in this section, we do the graphs of the inequalities that they give us. Those are called constraints. So that if you're running a business that is you only have so many employees, you can only work them so many hours. Those are constraints. So you can only produce so much stuff. What we do with those constraints is we say, okay, this is what our business can do. And that's what that unshaded region, that's called that feasible region. That's what your company can produce. And again, it's somewhat abstract, so we don't know what we're producing or anything, but that's what can happen. And then we're going to be given another, it's not an equation, it's just an expression, but sometimes they'll do it as an equation. we want to maximize or minimize that. So there's some objective. It might be the cost of running this business that we want to minimize. It might be the profit from running this business that we want to maximize. So we will have, so there's sort of two sets of things. There's a constraints, which is going to have 4 or 5 different inequalities, and then we will have a objective function, and we want to either minimize or maximize that. And remember what we were talking about, we'll kind of just go through here. We got through this part. So something like this, this has 3 constraints with 1 objective function, which is just x plus y. They wanted to maximize that. So what we did is we graphed the constraints, the inequalities, and we got something like this. The feasible region, and because of the way they're doing it, is the unshaded region. And there was this theorem or this belief that the maximum was going to occur at one of the vertexes, one of the points where there was some intersection. And we kind of proved that that's always going to happen. And so that's what we're going to do is today we're going to set up a problem from scratch with no equations or inequalities, just words. So we're going to take those words, turn them into the constraints, turn them into the objective function, and then just do the same thing. Okay. And there's in your homework 4 or 5 of these type of problems. So the first few are graph it. There's a few that maximize like this type of problem. And then there's 4 or 5 something that are just word problems. You got to turn them into the equation. So, and to me, that's the hardest part, but it's also the most realistic. It's really what we want you to get out of this, because you go to your boss, he doesn't give you the equations. He probably doesn't know what the equations are. He gives you all the facts, or you got to get these out of someplace. Okay. And again, this went through the solution, so you could kind of click through. And this was sort of the proof that the endpoints are for any particular objective function. That's where the maximum is going to occur, because if you go a little bit bigger, it's not even in the feasible region. Your company can't do, in this case, 10, because it's not in the feasible region. So with this feasible region, D ended up being the biggest. And if you change the objective function, which they did here, slightly different objective function, it's still going to be one of these endpoints, because otherwise you're outside of the feasible region. So those are kind of the boundaries of the feasible region. Okay. So we did all that. This is kind of step by step. So what we're going to do is, first we will set up the constraints, the less than or equal to stuff. We will graph it. We will figure out what that objective function is. And remember, what we'll do is we'll just find where all those intersections are. And then one of those is going to be our answers. We plug those into the objective function to see which one gives us either the biggest or the smallest, depending upon whether they say maximize or minimize. And then we're done. Easy enough, right? Okay, so this is what we get. We get all these words. Where do we start? Typically, they say start reading at the beginning. But what I like to do is I like to sort of come to the end and try to figure out what we're doing. And I look for questions. And I look for question words. So I see something like how. This is a question. How many quarts of each should they make? So that's, and here's a question mark to have the largest profit. So what I know is I'm trying to get the largest profit just by finding this sentence with a question on it. Here's another question. So if I kind of look, it looks like they've got 2 questions here. But the question is how many quarts should they make each day to get the largest profit? So now when I come back to read this, I'm looking for what are quarts. And those are going to be my variables, because they don't know how many of those. So those are variable things. So Acme Baby Food mixes 2 strengths of apple juice. 1 quart of beginners. That must be one of the variables. Maybe I'll call that X. Juice is made from 30 fluid ounces of water. So, and 2 fluid ounces of apple juice. Those are specific numbers. Those are going to be part of my constraints, is what I'm thinking. Okay. 1 quart of advanced juice. Oh, see, we're looking for how many quarts. Here's a quart of advanced. Okay, that must be Y. So because I looked at my question first, I can go back and say, what are the 2 variables? I've got those labeled. That's kind of key. And then advanced juice is made from 22 fluid ounces of water, 12 fluid ounces of concentrate. So there's just 2 things that are mixed together. So those are also going to be part of the constraints. Okay, so I don't deal too much with that. Every day, Acme has available 30,000 fluid ounces of water. That's a constraint. They don't have more than that. They could use less, right? But that's as much as they have. And they've got 3,600 fluid ounces of concentrate. So again, another constraint. Acme makes a profit of 20 cents on each of beginners, 30 cents on each quart of advanced. And I see this word profit, and I remember from the question, they want me to get the largest profit. So I'm thinking, what is profit? Is that a constraint or is that an objective? It's an objective. So see, it kind of helps me by coming to the question first, but nobody teaches it this way unless you're dyslexic and you're used to going to the end first. I always read the back of the book first, see if it was worth reading, right? So go to the end first, see what the question is, and then you come here and then it starts to make more sense. Notice I haven't even read the thing yet because, again, to me, reading, anyway, we'll talk about that later, but I can pick out my stuff. I could then come and read the whole thing again to get the whole picture if you need to. But particularly in math, what I find is if I know what I'm looking for, I look for numbers because those are going to be part of what I'm looking for. And I look for those units because they tell me, is this part of a constraint or is it part of a objective function? Okay, so let's kind of put these things together now. So any questions on that or anything that wasn't clear yet? We're not? Okay. So I'm going to give myself some room here. I've copied it down and I want to just focus on getting the objective functions. So notice I took out the part that talks about, I'm sorry, I'm backwards. I want to focus on the constraints. I got rid of the objective function. Okay. So we just want to focus on the constraints. The nice thing when you go to set these things up is you can do it pretty much with a table. Okay. And sometimes we're going to see when we get to doing matrices, we'll use the same technique, but sometimes you can switch what the row and the columns are, and sometimes it'll work and sometimes it'll work better the other way. So this is kind of a trial and error. If things start coming together smoothly, you're probably doing the right thing. If things get complicated, try switching the columns. That's what I do. And I don't always know the right way, but I'll do with sort of beginners, and then I'll do my Y as advanced. And we've got 2 things that make this. Let's see, we've got water and we've got concentrate. And the beginners, 30 fluid ounces of water, 2 fluid ounces of juice. The advanced, 20 fluid ounces of water, 12 fluid ounces of concentrate. And I just sort of, we don't have to do this, but if you add 30 plus 32, you get 32. 20 plus 12, you get 32. That's fluid ounces, right? That's what the units are. How many, excuse me, how many fluid ounces are in a quart? I wasn't sure either. I had to look it up. 32. So it's kind of cool that we're making 32 and that gives us 1 quart. Okay, have to look it up. But so and the reason I was saying, wait, they want quarts and they're giving us ounces. Are we going to have to convert, right? And I looked it up. Oh, wait, 32 ounces is a quart. So we don't have to convert. So We also know in this sort of thing that the total amount of water we have is 30,000. And the total amount of concentrate is 3,600. And so what I do is, so each time I make 1 quart of beginners, I'm going to use 30x, 30 ounces of water times however many quarts I make. And the concentrate is going to be 2 times x. When I make an advance, I'm going to get 20 times y, however many quarts of concentrate I make, and 12 times y. Here's the thing, though, is a lot of times we're thinking of rho. We don't do 30x plus 2x, right? What we do is we've got the constraint is how much water can we use. 30x plus 20y has to be less than 30,000. So there's our first constraint. Just do it up here. And again, that's less than, it didn't say we had to use all the water, but we can use up to that because we don't have more. Then for the concentrate, we're going to get 2x plus 12y has to be less than or equal to 3,600. And that's all of the constraints we have, right? The rest of the problem we read dealt with the profit, which is our objective. Okay, we'll do that secondly. But all we got to do, well, there's two constraints that are sort of implied but not spoken about. And what are those two constraints? Good. Yeah, you can't use negative water, I guess, uh, or you can't make negative juice. So they're both going to be greater than or equal to 0. So that helps enclose our boundary. Thank you. Almost forgot about those. I always do, because they didn't mention that. But negative numbers don't make sense in this question. Negative juice. Okay. So what we're going to do now, before I move on to the next, I'm going to go ahead and graph this, just because I've gotten to this stage. I just need to get this into my graphing calculator, and then I'll be able to find the points that I need to use. So let's go ahead and do that. Let's see. Oh, I don't always do this, but I wasn't planning. My equations are out of the way, so we can actually just sort of enter them in. So what I'm going to do is I'm entered that first one. Now, the way I go about doing this is I take the number that is, well, I'm going to take this 30,000 and enter it as parentheses 30,000. Notice the 30x is going to have to come over to I'm solving for y is what I'm doing to put it in, because in my calculator I have y equals. So the 30x is on the left-hand side. I want to get it over here. How do I do that? I subtract it from both sides. On the left-hand side, it disappears, right? 30x minus 30x is 0. On this side, it's 30,000 minus 30x. I'm going to close the parentheses. And then now all I need to do is divide by the number in front of the y, so to get the y by itself. So I divide by 20. Notice I haven't written anything down. You might find it helpful to do that, but this will 20. This will graph it correctly. I was working with a few of you. One thing I did see is sometimes people will put the parentheses around the 20, but they forget about putting it on the top. Order of operations is off. Your line is not correctly graphed. So make sure you have, there's order of operations. You get your parentheses in the right. So the numerator needs to be in a parentheses divided by 20. We don't need a parentheses in the bottom because it's just a single item. So that line's going to be fine. Second line, we've got 3,600, so I do parentheses 3,600. Bring the x over, which is 2x, so I'm going to subtract 2x because it's positive. I need to make it negative to bring it to the other side. And then I need a parentheses. That's my numerator. I need to divide by the number in front of the y, which is 12. Now, the other constraint I can graph is y is greater than 0, right? Because I got y equals, so I can also do 0 here. I can't do x greater than 0 because x is a vertical line, and this system won't let me graph it. I haven't quite finished. I probably should have done this while I was going, but I want to make sure I got the shading right, right? So if I do this, y is less than all of this side, right? Y is less than, that means I want below is is the solution. So remember, I shade the opposite. I shade what's not the solution. So I want to shade above, and that's what's I've got going here, right? If I come over here, that's above, enter. It's already above, so I don't have to change it. Okay. Second one, same thing is happening. I solved for y. Y is less than all this. I never needed to flip the sign. So I want the solution to be below the line. So I'm going to shade above the line, and that's what's happening. Okay. And the thing is you'll get into a rhythm, and sometimes you'll find that these, the constraints are kind of going to be similar like this, and you might not have to change them too much. This one, I wanted y less than 0. So y greater than 0. Sorry, I want y greater than 0. So I want above. I want anything y to be bigger than 0. So I want to shade below because that's not what I want, and it's already shaded below. So I've got my shadings, but I go through that check. Don't just assume they're going to be right because, again, it's easy. I do this in my wife, when I go to Thailand, they speak Thai, obviously. I can understand quite a bit, but sometimes there's a word in Thai that's mai, which means not. I miss that word. So I don't know whether I know something about the store, but I don't know if we're going or not going today because I missed the mai. Same thing here. You could be half wrong most of the time. So I say I understand about 50%, but that means I'm 50% of the time I'm wrong. So just, we've got a 50-50 chance, but you don't want to just go by chance. Does that make sense? So let's go ahead and graph this. Now, 30,000 is a pretty big number. I don't know if I'm going to see this region or not. So I'm just going to graph it. In fact, I don't even know what my window is. Maybe I'll do a little bit. Let's go to window. We know we don't need any negatives, so my x minimum I'll make 0, and my y minimum I'll make 0. 30,000, that's a pretty big number. Let me just try 10,000 for my x, and maybe 10,000 for my y. And that's just a total guess. I'm either going to see what I need to see, or I might either have to go further out or come further in. So I take a wild guess, hit my graph. I think I'm out too far. I see a lot of things I don't want, and I see a little white space here. 10,000 was not the right, maybe 500. I don't know. And remember, what our solution is number of quarts. So I could maybe do a few calculations, but maybe I can only make about 1,000 quarts. Let me just come back here, and I'll just do a delete, take off 1 0, and see if this gets me close enough. That's better. I think I can. In fact, actually, this is pretty good because I see a point here, here. Remember, there's nothing down here. There would be a point here and a point here. So I've got 1, 2, 4 possible solutions. Okay, that's what I need to be able to see. So maybe it's a good thing. 1,000 was a good, 500 wouldn't have been big enough to see everything. Please come back. Okay, thank you. So are we okay so far? Questions? Yes, sir. Yeah. So on these, we're going X minimum is going to be 0, Y minimum is going to be 0 because we don't need negatives. The big part is we're guessing at how big do we need to make it. I went to 10,000. I went down to 1,000. Sometimes we just kind of, it takes 3 or 4 tries to get the right window or a good window. There is no right window. There's just a good window. And this is about the minimum I could have gone because I'm seeing where I'm right on the edge. 1,500 also would have been a good window, but so I do that. I don't mess with any of these things. You could probably move those around and stuff and maybe get a little nicer one. But what I'm going to do now is I need to find the intersections of these with these vertexes. So this one's the intersection of these 2 lines. This one's the intersection of the y equals 0. This one's I'm not going to worry about too much. I'm pretty sure it's 0, 0, right? Because that's going to be included. And then this one I can find not with the intersection tool, but with I'll show you. Let's just do this. So I'm going to now go second calc. So once I get the shading, the region, I then just go find all the corner points because that's going to be where it is. And so I use intersect for that. And I'm on this line here, which is, you see the little flashing line. That's one of the lines I want to be on because I'm going to try to get this intersection here. So I'm just going to hit enter. As soon as I do that, it jumps down to this line, which is also one of the other line I want to be on. So I'm just going to hit enter. And then it sits there, but it's asking for a guess. I'm going to hit guess because there's only one place that those 2 lines intersect. I could move it closer, but I don't have to. And it gives me that intersection point. I'm going to think that that's probably what the correct answer is. It's probably going to maximize with this, but I'm going to find the other one. So X should be 900, Y should be 150. And I write that, oops, I think I can write on here. So that's one possible answer. How do I get back? Here we go. I want to find this little point down here, which I'm going to, well, I won't guess. I'll just do it. Second calc, you want an intersection. And I'm not sure which line I'm on right now, so I'm hitting the right arrow. I'm on the correct one. Now, if you want to change lines, so it's a little, the up and down arrow will get you to change which line you're on. Notice if I hit up and down, I switch which line I'm on. But I'm on this blue line, and that's one of the ones I want to be on, so I hit enter. And then I'm going to arrow, I'm on this line here, and that's not the one I want to be on the x-axis. So I hit the down arrow. I'm now on the x-axis. Enter, enter. I don't get a sign change. What does that mean? I'm actually glad I did this. Does anyone know what that means? When they look for intersections, the way it actually does a calculation, and it's looking for it to go from negative to positive. That's how it knows it's intersected. What that's telling me is my window was not quite big enough. Maybe the solution is like 1050, and the intersection is actually just off the window. So what I need to do in this case, and most of you would say, oh, I messed up somewhat. No, you didn't mess up. We just need a bigger window. I'll show you. We'll go to the window. Oops, I have to hit enter to quit first. We'll go to the window. That's in the X direction. I'm going to make X 1050. Actually, I'm going to make it 1051 because I think 1050 is the answer. Actually, let me make it 1100. Don't try to be too confident, just be big enough, but don't try to be exactly. 1100 should do it. If we go back to the graph now, see, now I can see that the intersection's actually there. I was probably just missing it. I do it again. Second, calc, intersect. That's one of the lines, right? So I'm just going to hit enter. That's not one of the lines, so I'm going to hit down arrow. That's the line. So I wanted the line with the x-axis. So this is the key part. I'll hit enter and then enter again for my guess. Actually, it's exactly 1,000. The problem was is our window stopped at 1,000. It couldn't go to the other side. We could have been 1,001 and we would have been okay. So you can't, if you're right on that boundary, it's not going to find it. Okay. But again, you think you did something wrong because I got this error, right? So sometimes it's just, oh, I just need to make my window a little bit bigger and we're okay. So here's a solution. Make all beginners 1,000. And so here's another solution. Make 1,000 beginners, make no advanced. And again, that might give you the biggest profit depending upon, how much profit you get from each. But and then we could see that there's also 0, 0. And we'll find the last one. The last one's this x-axis, and that's making all advanced, right? I'm pretty sure. Yeah, so that's no x's, all y's. The way we can do that one is we go second trace. We can look for a value. And the value I'm going to put in is you can put in an x value. I'm going to put in 0 for x, but I got to get onto the right line. Let's see. Let me just see if it works. I put in 0 for x. I'm on the wrong line. Okay, so I'm going to hit trace. And let's see. I'm tracing around till I can see that little. And where I'm at is x like 250, y is up over 1,000. So let me get down here. So here's my little spider guy, I called him. This is my cursor. The line I want to be on is this lower line here, not this upper line. So I'm going to go down. Now that I'm on this line, if I go second, trace, and value, if I plug in 0 for x now, since I'm on the right line, it will give me the y value. Oh, it still doesn't. Ah, thank you. See? Down arrow. Thank you. So the value, yeah, it will jump around. So now I'm on the right line. 300. Okay, perfect. See, we need each other. We'll figure this out. So thank you. 0, 300 is another possible maximum value. And again, maybe that, the advanced is for whatever reason makes a bigger profit. So 0, 300 is our other. But one of these 4 points is going to maximize. And what we're going to do is remember the question on the maximize part, they gave us 2 different things to maximize. We're going to probably find one of these points maximizes one set of profit conditions. Another point would probably maximize one of the others. So you guys hopefully have those down. What I'm going to do now is go and write up the objective functions. We'll plug these ones in to those objective functions and we'll find our answer. But you see, we spent a whole, probably close to 50 minutes by the time we're done on one problem. But once you get going, the next one you do, it'll be a little bit quicker because they're very similar. And that's the thing is through repetition, you'll take, oh, this is just like that, boom, 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 and you'll be going forward. Okay. So go back to the slideshow. Let's see, hopefully it's got everything there. Now I got rid of the constraints and I'm just going to focus on the objective functions because actually I've already done the constraint stuff. So let's talk about this objective function. It's a little easier to work with. So we make a profit of 20 cents on each quart of beginners, 30 cents on each advanced. So objective functions don't have too much money, so what that is we're going to make a profit of 20 cents. Now you could do it either as 0.2, but when they're doing 20 cents, it's sort of like they're indicating the answer should be in cents. So this will be 20 times x plus 30 times y. Okay. And again, you could do 0.2 and 0.3 and have your answer in dollars. But if we want our answer in cents, then we would do it this way. So sometimes look for that in WebAssign. You might have a right answer, but your units are, you're putting it in dollars and it wants it in cents, or vice versa. Okay. So now we would plug in all of those. Well, certainly if we plug in 0, 0, profit is 0. You don't make anything, you don't get anything. So that's not going to work. The other one was what, 900 and 150. But you see the advance is making a little bit more money per each. So maybe this one, let's see, 900, 150, 0, 300. So, basically just plug them all in. So let's see, we've got 900, 150. We've got 1000, 0. We've got 0, 300. And I did the 0, 0 is already 0. So 20. This last one's easiest. It's going to give us 9,000, right? This one is 0. 2 times 1,000 should give us 20 times 1,000 should give us 20,000. That's penny. So that's bigger than the other one. But this one up here, 2 times 9 is 18 with 1, 2, 3, 18,000. 3 times 15 is 45 with 2 zeros. So I think this 0.900 150 is going to give us the biggest value of 22,500 cents. So about $225 after all that work. Not a lot. Does that make sense? Okay. So the solution for this one was 900, 150. That gave the maximum. They also want us to see, well, what if it was 40 cents on beginners and 20 cents on advanced? Then which one? That one I'm going to lean towards probably this one of 1,000 and 0, right? That's going to give us 40,000. If you tried 900 and 150, I think you're going to find it's going to be a little bit less. 9 times 4 is 36 with 1, 2, 3. 2 times 15 is 30, plus 2, that's 39. So just a little bit less. So the second, if this is our profit function, this one, its maximum is to just produce all beginner and no advance. See how that is? Is depends on how the market's going. These are how we make our business decisions. Okay, today we're going to make all beginners. That's what's going to get us the biggest profit. Again, when you're making your decisions, this is money, bottom line profit is one part of it, but you also got to think, hey, there's some people out there who want that advanced. We got to make a few of those. It's not going to, we won't make as much money, but we got to keep our customers happy, and maybe in the long run we will. So don't make all your decisions simply based on the bottom dollar line. You know, we bring all this stuff in, but at least numerically, this is saying this is the best numerical will give us the biggest profit. But that's not always, we got a lot of different things we want to do when we run a company, not just all based on the numbers. But this shows us that the same feasibility of what we can produce will that what we should produce might change from day to day based upon the economies that are going on and what our customers are wanting and stuff. Does that make sense? Does it make sense on how to set these things up, kind of do a table? Constraints first, and that's sort of to me the hardest part, because then you got to get the graphs right, you got to shade right, you got to see this, find all your, but once you got it, look how easy it was. We got all the points, we just have to plug them all in to the objective function. So I kind of wait till the end for that. And you'll see there's about 4 of these, and by the time you do all 4 of them, the last one, you'll almost probably be able to set it up without too much forethought. It'll just flow in, and that'll be good, because then we'll come back to this. And what we're going to do with this type of stuff is we'll use matrices, and we won't just have 2 variables. We might have 5 variables, and with a matrix, it can handle all of that. Because remember, it's with the matrix, we can figure out where those intersection points are. We'll get some new techniques where we'll get the calculator doing it for us. Okay, but it's this class. It is really important to not only have a graphing calculator, but to be using it from the beginning. And that's why I spend time showing you how to use it, because that's our method. A lot of times, the sometimes we're even trained show the by hand way, and then let you figure out the computer on your or your calculator on yourself. But I'll try to as much as I can. And like office hours, sometimes you're pushing the wrong buttons and it's just not clear. But working together, if I see what you're pushing, I can say, oh wait, no, you're close, but you got the parentheses, but it needs to be this side, not that side. It's very small things can make a difference. Okay, but practice setting these kind of things up, because again, that's where the real world takes us. Life gives us word problems. Life doesn't give us equations. That's where our part is. So if you get to the place where you can do that, uh, and again, I was in financial planning for years, 13 years, and I made, at that time, that was almost 40 years ago, I could make $100 an hour doing another agent. He made $1 million a year back then. Because he was a good salesperson, but he didn't know how to use a calculator, and he didn't. And I didn't tell him how easy it was for me to do it, because I made him think. He gave me something. Made him wait a couple days, even though I was done in 10 minutes. But I made him think it was a lot of work, so I got paid good too. But I could set it up. I would go to books and look things up. I'd look up the equations and stuff, but I could pick out what needed to be done. And so that gave me a place. I was not a good salesperson. I would have starved to death if it was based on me selling. But I found good salespeople. I did their back work for them. They made a lot more than I did, but that's okay. I made enough to put food on the table. So find what you're good at. And if you're good at sales, understand this a little bit, but yeah, pay some kid $100 an hour to do it for you. You go out, make the sale, and make 1,000 an hour or whatever. So there's those different skill sets that we have. Know what your skill set is, but try to understand some of the ones that maybe aren't your strengths, so that you know, and maybe you would have, if you would have negotiated 50 an hour, I would have still been happy. But anyway, it all works out. Hope he's not listening, but like I said, it was 40 years ago. Any questions? All right. So again, just practice of this over the weekend. Uh, my goal is by Sunday or Saturday morning to have a lecture up for 1.15, the next one, so that over the weekend, hopefully you can take a look at that. So then on Monday, we can focus on working some of the problems and not spend so much time on the theory part of it. Okay, awesome. Thank you, guys.